Hello and welcome to Maths with Jacob. This lesson will focus on curved graphs. In the last few videos, we saw how to graph straight lines on the number plane. The following equations give examples of straight lines. The first one is y equals x plus 1. Next we have x plus y equals 5. And the third example is 2x plus 3y equals 6. The above three equations are straight lines because the powers of both x and y are 1. So that's y to the power of 1, x to the power of 1, and it's the same for the next two. The following are simple examples of curved graphs. Y equals x squared, y equals x squared minus 1, x equals y squared. Can you see the important difference between the equations for straight lines and equations for curved graphs? And this is the answer. The equations for straight lines have powers equal to 1 for the variables x and y. So here, all the powers of x and y are 1. The equations for curved graphs have powers other than 1. That's an x squared, y squared. That could be x to the power of 3 or x to the power of 4. So what I'm saying is, one or more of those variables has powers not equal to 1. And that's the reason they are curved graphs. Let's look at two simple examples. Here's the first one. One of the simplest examples of a curved graph is y equals x squared. So let's consider this equation. We can create a table of values for this equation. We can then plot the graph. So I've just suggested the values starting at -3 and going all the way through to 3. If we substitute the values of x in one at a time, remembering y equals x squared. So to obtain the y value, just square the x value. 3 squared is 9. 2 squared is 4. 1 squared is 1. 0 squared is 0. -1 all squared. That's what this means. You have to square whatever the x value is. So -1 all squared is 1. -2 all squared is 4. And -3 all squared is 9. Because we don't have a lot of room here, I've just plotted those 5 points there. So from here to here, I've plotted those points. If you had more room, you could go up here and you can plot 3, 9. That would be up there somewhere. And -3, 9. But you can see that when you join those points up like that, you actually have a curve. And this curved graph is a very special and famous curved graph, which we will meet quite often in the years of schooling ahead, and it's called a parabola. That's what that's called, a parabola. And here's one more example. It's similar to this one, except we've added 1. When you add 1, all it does is move the parabola one place up along the y-axis. So here are the 7 points. There they are there. I've plotted all of them. 3 squared is 9, plus 1 is 10. 2 squared is 4, plus 1 is 5. So you do that, get all the numbers here, plot the points, and there you end up with your parabola again. And because it's plus 1, that parabola moves one place in that direction. So this video has given us a very simple introduction to show us the difference between straight line graphs and curved graphs. And we've seen two simple examples where we've seen that curved graphs occur when you have, for example, a 2 for the power of x and a 2 for the power of x. But it also can occur when you have 3, 4, 5 or whatever. As long as they're not 1, you will end up with curved graphs.